chapter 10, section 8. Let me ask you a question. If you were asked to define a circle, so here's a nice circle, how would you define a circle? That's it. 360 degrees. Josh?
A bunch of very, very, very small lines that make up very round, a lot of sides.
Okay. If you could zoom in, maybe you could imagine there are tiny little short pieces that go around making that circle. Okay. Anybody else? Define a circle. All points are equidistant from the center. What does that mean, equidistant? It's kind of a big word.
Yeah, like a point. Yeah, right there.
Here's a point. I don't know what it is, but it's a point. And what about it?
If you were to put out something else, those 2 points
They'll be those 2 points are the exact same size.
the 2 segments.
If we measure to the center, then let's get another point over here. X sub 2, comma, Y sub 2. And we measured to the center. What about it? It's going to be exactly the same. And there's pretty close to our definition. A circle is the set of points in a plane that are equidistant from one point called the center of that circle. And these equal distances over here, we have a name for it. What do we call it?
Radius.
The radius. That's just the radius. And we've talked about that before. Well, let's take this red point. Let me move my radius right over here. That fits them both. Let's take that red point for just a moment. I said it was some x and some y. Let's imagine that this is right at the origin of a graph. So if I went over x and then I went up y, that would form a right triangle. And if we called this r for the radius, what's the relationship between x, y, and r? The Pythagorean theorem. X squared plus y squared equals r squared. Well, guess what you just told me? The equation of a circle. X squared plus y squared equals r squared. It comes from the Pythagorean theorem. There's a little picture that's kind of like what I drew over there. This is a circle that has its center at the origin. Later we'll learn about moving the centers around, but if the center's at the origin, that is the simple equation of a circle. So right down here, if I want to move the center, and we often use the letters h and k, then that x squared plus y squared equals r squared just gets slightly adjusted. Notice it's x minus h and then squared, y minus k and then squared. So these numbers are the opposite, negative is opposite values of where the center is located. So let's try it out right down here. They say write the equation for each of these circles. And they first say we have a circle center 1, -8, and radius is 7. Well, if I use this idea right up here, I am going to say x and then the opposite of that 1, -1, quantity squared, plus y, and then the opposite of -8, which is what number? Plus 8. Quantity squared equals, and then what do I do to the radius? I square it. What's 7 squared? 49. That is the equation of the circle they just described. So it's pretty easy. The circle graphed at the right, we're supposed to write the equation. They say, oh, the center happens to be 0, 4, and the radius is 3. I don't know why they told us all that information. Help me out. X minus 0, quantity squared, plus y minus 4, quantity squared, equals 9. Now, we wouldn't leave the x minus 0 because x minus 0 is just x. So we would say x squared plus y minus 4, quantity squared, equals 9. That would be the equation of the circle. So writing equation of circles are pretty easy. Write the equation of a circle that has this center, and it passes through this point. Well, let's start out by again filling in x minus h quantity squared plus y minus k quantity squared equals the radius squared. And I know the center, so I can start x
Minus plus 2.
plus 2 quantity squared plus y
Minus 4.
minus 4 quantity squared equals, we don't know, do we? R squared. Now, what can I do with this? It's called an ordered pair. What are the values, the letters in the ordered pair? X and Y. An ordered pair are an X value and a Y value. Well, why don't we take this X and Y value and substitute it into the X and Y, and we'll be able to figure out what the R value is, or the R squared value. So X happens to be negative 6. Negative 6 plus 2 quantity squared plus, what's the Y? 7 minus 4 quantity squared must equal the radius squared. Well, what's negative 6 plus 2? Negative 4. What's negative 4 squared? 16. Plus 7 minus 4 is 3. 3 squared? 9. What's 16 plus 9? 25. I now know what the radius squared is. Now, what is the radius? 5, square root of 25, which is 5. But since they wanted us to write the equation, I really want to know what the radius squared is, which now I know. The radius squared is 25. So I can write the equation just using this line right up here. X plus 2 quantity squared plus y minus 4 quantity squared equals 25, because I figured out what the radius squared was. So we start the same with that basic circle formula. We fill in the center. We don't know the radius, so we just fill in the x and y, and we figure out what the radius is. And then we can write the equation. The equation of a circle is this. Now that looks a little different. They want us to figure out what are the coordinates of the center, and what is the measure of the radius, and then graph that thing. Well, this isn't the same form we have been looking at. X squared plus y squared minus 8x plus 2y equals negative 8. That's a different form. We have been looking at binomials squared. It's a binomial right up here. A binomial squared for the x's and a binomial squared for the y's. Well, thankfully, we learned in algebra, and we'll probably have to review it, something called completing the square. Does that ring a bell in anybody's brain? That term? Completing the square. Let's look at it. I need to take my x values, my x squared minus my 8x, and I'm going to leave some room to complete the square. Then I'm going to do my y's. Plus y squared plus 2y. I'm going to leave some room to complete the square. Equals negative 8. Completing the square is the process of changing this into a trinomial that will factor as something squared. We want to change it to a perfect square trinomial. And how we do that is we take this b value, remember ax squared plus bx plus c. We take the b value, the negative a, we divide it by, ring a bell yet? 2. And then we do what? Perfect. Square it. That's exactly what we do. What's negative 8 divided by 2? Negative 4. Squared? 16. I add 16. That has turned this into a trinomial that's called a perfect square trinomial that will factor as some binomial squared. We'll come pick it up in a minute. But we just got through adding 16 to the left side of an equation. We have to do it to the right side. Whatever I do to one side of an equation, I have to do to the other side of the equation. Now let's do the same thing on the y's. We want to complete the square on this. Can you tell me the c value, the number I need to put there to complete the square? It'll be plus 1. I'll take the 2, I'll divide it by 2, which is 1, and I'll square it. 1 squared is 1. Plus 1. We're doing the same process as we did right over there. Now what do I need to do on the right side? Plus 1. I added 1 on the left, I better add 1 on the right. Now, how does this trinomial factor? Well, it's going to factor as x, and then half this b value, minus 4, quantity squared. If you took x minus 4 and multiplied it by itself, or squared it, you would get x squared minus 8x plus 16. That's the factored 4. We're going to try the same pattern over here. Plus, we'll do with our y's. Can you tell me y something? Plus 1. Just half that too. Plus 1, quantity squared. If you squared that out, you would get this trinomial. Y squared plus 2y plus 1. Equals, well, do the math over there. 9. It equals 9. And I want you to look at what we have right here. You recognize that form? That's standard form of a circle. Where is the center of this circle? Positive 4, comma, negative 1. That's the center of the circle. Eventually, they're going to want us to graph it. Let me do this. 4, negative 1. 4, negative 1. Right there is the center of my circle. What is the radius of this circle? Not 9.
Oh, it's
3. It is 3. Where did 3 come from?
because you have to square the radius.
Square root of that 9. That 9 is the radius squared, so we have to take the square root of that number. So I'm supposed to go out 3. Well, if I'm going to graph this, 1, 2, 3. That'd be a point on the circle. 1, 2, 3. Maybe I'll do a line. 1, 2, 3. 1, 2, 3. And then you have your compass, or maybe if you're real good at freehand, you can just draw a circle.
That was the minus the circle.
Oh, look at that. Almost I did it. There you go, we graphed it. So when we have it not in standard form, we have to rearrange it, complete the square, and then it is in standard form as soon as we've done that. Same idea. Let's try it right here. X squared plus 8x, we'll need to complete the square on that, plus y squared minus 14y, we need to complete the square on that, equals, I'm going to subtract the 40, minus 40. I want to move that constant, that number to the other side. So what will we complete the square with on the x's?
2 squares.
16. 8 divided by 2 is 4. 4 squared is plus 16. Plus 16. How about the y's? Plus 49. Half of negative 14 is negative 7. You square it, plus 49. Plus 49. Now, the x's. How will they factor? X plus 4. Since that's a plus 8, half of that is a plus 4. Plus the y's? Y minus 7, quantity squared, equals 25, equals 25. I have it in standard form. Tell me what the center of this is. Negative 4, positive 7. What is the radius? The radius is 5. So if I was going to graph negative 4 comma 7, that's this point. 1, 2, 3, 4, 5. 2, 3, 4, 5. Right about there. 1, 2, 3, 4, 5. Should get my compass out. 1, 2, 3, 4, 5. You have a compass. I'm going to get my compass out. And we'll do a green circle. So it's real easy with your compass. Just put your point right up there. Open it out to the size. Hey, I was pretty close on my 5 mark up there. There it is. Tornado sirens are placed strategically on a circle around a town so that they can be heard by all. Write the equation of the circle on which they are placed. If the coordinates of the siren happen to be at negative 8, 3, negative 8, 3, so here's one siren, point A. And negative 4, 7, negative 4, 7, there's siren B. And negative 4, negative 1, siren C. They want the equation of the circle. Now you don't get your compass out and try to guess where the center is, and then move it around and try it again, and move it around and try it again. We are going to do a construction that we learned earlier. If I make chords here and here, there's some circle that comes around through this. I don't know what it is exactly, but there's some circle that comes around. Not a very good one. But we know that if I have chords and if I do the perpendicular bisector of those chords, those bisectors, those perpendicular bisectors are what of that circle? They're diameters of the circle. And where two diameters cross, where must you be? At the center. So this is a construction problem. Remember how to do perpendicular bisectors? I'm going to put my point there. I am going to open it up over halfway, which I am. I'm going to put a mark above and a mark below. I flip to the other side. I do the same thing. I cross it above and I cross it below. Oh, I twisted it so much I can't find it. Put it back. And I cross it below. And those X's should be on my diameter. So running right through there, that should be a diameter of the circle. I'm going to get rid of this green thing that I drew because that's not very accurate. We'll find the exact one. Same thing over on the other side. I'll do this one in blue. I put my point right there, make sure I'm over halfway, an arc on either side. So these are my blue ones. I'm going to flip it around to the other end. I am going to cross right there and right over here I cross. And that should be giving me my diameters again. Those perpendicular bisectors are on diameters. That's pretty close. Where's my blue one? There's my blue one. So I appear to be intersecting right there. Can you read the ordered pair of that point? -4, +3. -4, +3. We'll see how good a job I did. Where did my compass go? I shouldn't have gotten rid of it. We'll do it in green, since that's what I was doing earlier. I just put my point right there. I'm going to open it to the side so it hits A, and I draw a circle. Did I hit my other points? Of course. There you go. Write the equation of the circle. All right, so let's write the equation of the circle. Look at these values. Help me out. Something squared. X what? X plus 4, quantity squared, plus y minus 3, quantity squared, equals I can tell the radius. I'm going to look right here. 1, 2, 3, 4. So the radius is 4. I square my 4 is 16. There it is. There's the equation of the circle that those sirens are placed on. Find the point or points of intersection between this and this. What shape is that first equation? That's a circle. It's a circle whose center is where? 0, 0. Yeah. If it's just x, it's x minus 0. 0, 0. And whose radius is 2, square root of 4. What shape is this y equals x? A line. That's a line. That's slope-intercept form. Y equals mx plus b. The y-intercept just happens to be 0. So they want to know where they cross. We're not going to use the graph to get the answer. I'm going to get a graph afterward to see how well we did. We are going to use algebra and substitute. If y equals x, I'm going to replace the y with x. X squared plus, and instead of y, I'm going to replace it with x. X squared equals 4. What's x squared plus x squared? 2x squared equals 4. So divide by 2. X squared equals 2. What do you get for x? Say that again? Square root of 2. In fact, there are two values. Plus or minus the square root of 2. To get rid of the x squared, I have to take plus or minus. Because when I square a positive or a negative, I get a positive answer. There are two possible values for x. Positive square root of 2, and there'll be some y that goes with it. Or negative square root of 2, and there'll be some y that goes with that. So how do I get the y? Well, let's come back to here. Y just equals the x. If my x is positive square root of 2, what's the y? positive square root of 2. If my x is negative square root of 2,
Negative square root.
my y is negative square root of 2. There's the answer. This is why we couldn't get it from the graph. Even though I have a center at 0 and a radius of 2, so I'll do it this way.
How do you know the center was at 0?
How do I know the center's at 0?
Because it just says x and y.
Because there's not an x plus 7 or something.
Uh,
Just x by itself must be x plus 0 or minus 0.
Okay, so that says x squared plus y squared equals 4.
Mhm.
What's x? I didn't-
That's x squared plus y squared is 4. And if I graph this line, y equals x, the y-intercept is 0, and the slope is 1, up 1, right 1, up 1, right 1, and I drew this line, I can tell that sure enough it does intersect in 2 spots, but exactly where those 2 spots are, I would never figure out exactly where those 2 spots are where it intersects. There are the exact values of where it intersects. So we have to use algebra to get that one. Let's go to your book. Page, where are we, 760? Page 760. Number 1. It says, write the equation of each circle. Center is 9, 0. Let's start writing. X minus what? X minus 9, quantity squared, plus
Y squared.
y squared. That's just it. If it's 0, there's nothing to add or subtract. Equals, and what do they say the radius is? Radius is 5, so it equals what? It equals 25. We're done with number 1. Number 2. The center is at 3, 1. Okay. X minus 3, quantity squared, plus y
Not Y squared.
minus 1, quantity squared. Once we know the center, we can do all that stuff. Diameter is 14. Think a minute.
Divide by 6, 49.
49. If the diameter is 14, the radius must be 7, and we'll square the radius and get that number. 7 squared is 49. Number 3. Center is at the origin, so if it's 0, 0, do the left side for me. X squared plus y squared equals, and then what do they say about the radius? Oh, they don't. It passes through 2, 2.
So 2 squared.
If I pass through the point 2, 2, how am I going to get that radius?
Pythagorean theorem.
Okay, sure. Which, guess what? It's just filling in x and y right over here. So you're both right. 2 is an x and 2 is a y. 2 squared plus 2 squared must equal the radius squared. Well, 2 squared is 4. What's 4 plus 4?
8.
8 is the radius squared. Now I can write the answer. What's the equation of the circle?
X squared plus y squared equals 8.
X squared plus y squared equals 8. Don't square that 8 because 8 is already the radius squared. So what's the radius?
4. Not 4.
Not 4. Not 2.
3.5.
What do you do to get the radius? Square it. Square what? Square root of 8. Whatever the square root of 8 is, which is 2 squared to 2, or some decimal.
Oh, equals 8.
What, David?
R squared is 8, and that's what we want in the equation of a circle, is R squared. Number 4. Yes, ma'am. How did I know? We knew the equation of the circle was that. And this point 2, 2 is an x value and a y value on the circle. So all I did was I filled in the x, which was a 2, and the y, which was a 2. Number 4. Center is at negative 5, 3. Okay? x
Plus 5.
plus 5 quantity squared plus y
Minus 3.
minus 3 quantity squared equals, well, r squared. What can I do with that 1, negative 4?
Let's plug it in.
Put it in the one.
Yeah, put it in the x and y. X is 1. 1 plus 5 quantity squared. What was y? Negative 4? Negative 4 minus 3 quantity squared. That's going to be whatever r squared is. Well, 1 plus 5 is 6. What's 6 squared? 36. Negative 4 minus 3.
49.
Negative 7 squared is 49. So you add them together, you get what?
So amazing.
Yes.
85.
85 is r squared. So my equation is x plus 5 quantity squared plus y minus 3 quantity squared equals 85. I'm just copying down the first part of the equation that comes from the center, and then I put the r squared value on the other side of the equal sign.
Anything is
Number 5. Give us a graph. Let's see what we can do with that graph to write the equation of the circle. Do we know where the center is?
yep. Yeah, 2 more.
2, 1. So x
Minus 2.
minus 2 quantity squared plus y right here,
Minus 1.
minus 1 quantity squared equals,
R squared.
I agree. Can you tell me what r squared is?
2.
4. The radius is 2. We can tell right from the graph. The radius is 2. So 2 squared is the number 4, and we're done with the equation of number 5.
Nice.
Yeah, nice. 6.
That's coming to think
Oh, why would it be so easy on the test? Number 6, we have a center, 3, negative 4. So I'm going to go x minus 3 quantity squared plus y plus 4 quantity squared equals my radius squared. Can I read the radius off this graph?
No.
No. It's going some diagonal. So I don't know the radius on this one. So what do we do?
Plug in this one.
Substitute in what?
X is y.
Which x and y?
0. 0.
The 0, negative 6. 0 minus 3 quantity squared. Negative 6, is that what it was?
Yes.
Negative 6 plus 4 quantity squared, that's the radius squared. Let's see, negative 3 squared is 9. Negative 2 squared is 4. So
13.
that's 13. So I know my answer is x minus 3 quantity squared plus y plus 4 quantity squared equals what number? 13. Because we solved for the radius squared.
And then do we put 13 squared?
Do we put 13 squared?
No.
That is the square.
That is r squared.
Yeah.
That is r squared. So it's 13. Number 7. For each of the given equations, state the coordinates of center and the measure of the radius, and then do a graph. Here's one of those things that we do what?
The perfect square.
We want to make a perfect square trinomial. Do you remember what the process is called?
Perfect square.
Completing the square is what it's called. So when I write it down, I leave myself a little room to complete the square after the x terms and then after the y term. They already even had it all in the right order for us. Okay, what number completes the square on the x's? Plus 9. Half of negative 6 is negative 3, squared is plus 9, and so plus 9 on the right side. What completes the y's?
Plus 4.
Plus 4. Half of 4 is 2. 2 squared is 4. Plus 4 on the right side. Okay, let's write these x's. Something is squared there. X minus 3. Just half that minus 6. Plus, how about the y's? Y plus 2. Half that 4. Quantity squared. Equals 16. So there is the equation in the standard form. What's the center?
Plus 3 minus.
Plus 3.
3, negative 2. There's the center. What is the radius? It is 4. The square root is 16. So there are actually the first answers. They say, find the coordinates of the center, we did. To measure the radius, we did. Then we're supposed to graph. We will. The popular people who actually are prepared, huh? You're a good man, Josh. Don't let anybody tell you anything different today. Center is 3, -2. So on your graph, you know you go to 3, -2. There's our center. I'm going to use my handy-dandy compass that I always bring to class. My radius is 4, so all I have to do is I put my compass point there in the center.
Oh, yeah, right on.
I'm going to open up my radius to 4. 1, 2, 3, 4. Oh, I can't get exactly 4. I can get close with mine. There we go. And I graph my circle. So you should have perfect circles because we have compasses in geometry class.
Name.
So you don't even need that nifty little tool. This tool is so fun as you guys are working on it. This tool is so fun because I can draw ellipses. I can draw squares. Triangles. Ooh, I had a little dip on that one. Anyway. Number 8. No, we all need little smart pads.
That moment when you're
You
comfy.
make houses for you?
And then I'm when you're
Touchscreen notebooks, laptops.
By all means, do it.
Number 8. X squared plus y plus 1 squared equals 4. You can tell me the center directly from that equation. What's the center?
No.
0,
Negative.
-1. 0, -1, because there's nothing added to the x, and there's a +1 on the y. So 0, -1. And what's the radius?
2.
2. They have it equals 4 squared, so square root of 4 is 2. Oh, we're already done with our first 2 answers. You thought the last one was easy.
Where's going?
0, -1. My handy-dandy compass. My radius is 2. I was looking for the hyperboreal circle.
Mine is like
Mine's a little wiggly.
Well, where's your compass? It should be perfect.
I would be doing this more better.
more better.
I'd be doing this better.
Radios, number 9. 3 radio towers. Hey, this sounds familiar. Are modeled by the points, and they tell us the locations. They want us to determine the location of another tower that's equidistant from all 3. Where is that other tower if it's going to be equidistant? I mean, concept-wise.
The center.
The center of a circle. Those all 3 are going to be on the circle, and it's going to be located at the center of the circle. So we need that compass. Can't freehand this thing. Let's see. They told us where these were all located.
8.
4, 5. 4, 5, 1 tower. 8, 1. Second tower. -4, 1. A third tower. Wow. There's supposed to be a circle that goes through that. What do you think? If you're given any 3 points, as long as they're not on a line, if you're given any 3 points, do you think there's a circle that will go through those points?
No.
The answer is yes. any three non-collinear points, you can find a circle that goes through them. And we can do it graphically, just like we're doing it right over here. It's kind of cool. So if you need to say, hey, I've got these 3 points, where's the circle that goes through them? Oh, you know how to do it. What do? We start with this chord.
There's a circle that goes through these.
There's a circle that goes through those, and we are going to find it. Doesn't look like it, does it? Trevor?
If you're like kind of like a kid that's big, like 20-foot mark on the ground, you want to find the circle. Would you just use like a pin and just like you put a string and you'll put a stake down and do that? Or
Well, notice what we're doing. We're doing it on a coordinate system. So to do it like we're doing it, you would actually have to model it on a coordinate system, draw it out, get measurements and draw it out. Choose a point to be the origin and then draw it out. And then once you found where the center should be, you could use a string and pull it out and it should go through all your points. But we'd have to model it on a coordinate system first. Did I already get my compass out? I did. There it is. Okay, we need to bisect these things. So you remember how to bisect. I put my point on one end. I open it more than halfway. I'm going to draw an arc above and below. I go around to the other end of that chord. And I cross the 2 arcs that we did. And then you can use your straight edge and you can draw a line right through them. I'm going to have to adjust mine here a little bit. And I'm going to do the same thing now to that other chord. I'm going to bisect it. You can look in the desk, but I think some people have borrowed mine and not returned them. I used to have 3 or 4 of them in there.
Yeah, it doesn't appear to be so. Get them in there.
Now, if you do it accurately, you should locate a center. I don't know where your center is. My center looks like it's at 2, -1. And I am going to test it.
Oh, by drawing a circle.
By drawing a circle.
My T was a little bit outside of mine. I can do my compass right.
Well, when you're doing anything graphically, it's not going to be perfect, but wow, pretty close.
So I was just
Pretty close.
so how far past do you go past the middle point to get right at the dead center?
How far past the
Yeah,
middle
like
point?
when you're
Oh, the farther you get, the farther away your X's are. You just need to be past the middle point.
okay.
All right, are we supposed to write the equation of this thing?
Yeah,
write the equation.
We're supposed to do 2 things, I think. First, tell where that tower is. Well, 2, -1. That's where the tower is, at the center. And then if I'm going to write the equation, I can start with the center because I know where my center is. So x minus 2 quantity squared plus y plus 1 quantity squared. Can we read the radius right off our graph?
6.
No, we can't. Maybe 6, maybe not 6. Mine doesn't look like 6. Mine looks like 1, 2, 3, 4, 5, 6 point something. Looks like it's a little bit bigger than 6. So who can tell me? What do we do?
We find a point.
We find a point on that circle. Can you tell me a point on the circle?
S.
S, sure. S happens to be 8, 1. I just need a point, any point. I'm going to fill in the 8, 1. It's x and y. 8 minus 2 quantity squared plus 1 plus 1 quantity squared equals the radius squared. 8 minus 2 is 6. 6 squared is 36 plus 1 plus 1 is 2. 2 squared is 4. So what's the radius squared?
40.
40 is the radius squared. So my equation, x minus 2 quantity squared plus y minus 1 quantity squared equals 40. Now, is that just a little over 6 for the radius? How would you tell?
Y plus 1. That's right.
The y plus 1? It's y plus 1. Can you tell me what the radius is on this circle?
How would we get it 40?
Square root of 40. What do you get on your calculator? Square root of 40. There you go. Just a little over 6, like we suspected it was. Number 10. Cross off 10.
Yes.
We did one.
Thank you.
11. Find the points of intersection, if any. All right, between each circle and the line with the equation given. So x minus 1 squared plus y squared equals 4. And they tell us the line is y equals x plus 1. We do just like in the example. I know a value for y, so I'm going to substitute it into the equation and solve. So if I have x minus 1 quantity squared plus my y has to be squared. What does y equal? X plus 1, which I have to square, equals 4. So we're going to have to square some things. That x minus 1 has to be squared. Now remember that when we square things, we multiply them by themselves, right?
Yep.
Don't try to square each part. That would give you the wrong answer. X plus 1 has to be squared.
Can we just use oh,
There is a formula. I'm going to do it the FOIL method, and then I'm going to run through the formula. So I'm going to use FOIL. Back on the left side, the first term's x times x is x squared. Outside is negative 1x. Inside is negative 1x. And the last terms are plus 1. I'm going to simplify this one before I go to the second one. X squared, and then what would that middle term be? Minus 2x plus 1. Let's look at this a minute. This answer, we can use a formula. If I take, and I'm going to come back up here, if I take the x, the first term, and square it, x squared, then I multiply them together. What's x times negative 1? Negative x times 2. Multiply them together times 2, because there's always 2 of them. Negative 1 times 2 is negative 2x. That's the middle term. And then you square the last thing. Negative 1 squared is a positive 1. I'm going to do that when I do this one. Plus, I'm going to square the x. I don't need parentheses. X squared. I'm going to multiply it together. 1x times 2 is plus 2x. Then I'm going to square that 1, plus 1. If you use FOIL, you get the same answer. You know the formula, it's faster. Well, x squared plus x squared is called 2x squared. Negative 2x plus 2x, they cross out. 1 plus 1 is 2, equals 4. So I'm going to subtract my 2. 2x squared equals 2. I'm going to divide by 2. X squared equals 1. Can you tell me what I do to get x?
square root.
Put something in front of that square root. Plus or minus. Plus or minus the square root of 1, which is plus or minus 1. There are two x values. They can be a positive 1 or a negative 1. So I'm going to write x can be a positive 1. There'll be a y that goes with it. X can be negative 1. There'll be a y that goes with it. And how do I get the y's? Right up there. We substitute it back in. Y equals our x plus 1. So if it's a 1, well, what's 1 plus 1? 2. When it's a 1, I get a 2. When it's a negative 1, what do you get? 0. There are your answers. These cross in two places. You could graph it out. They don't ask us to. And you could tell that, yeah, those answers look right. Try one more of these. X minus 2 quantity squared plus y plus 3 quantity squared equals 18. And this this time the equation of the line is y equals negative 2x minus 2. Again, I'm going to substitute. I have a value for y that I can substitute right where that y is. X minus 2 quantity squared plus negative 2x minus 2. Negative 2x minus 2. That's the y. Plus 3. And that has to be squared. Equals 18. We're going to simplify on that second one, right? Let's square this first one. I'm going to use the formula. Square the x squared. Multiply it together times 2 would be minus 4x. Square the negative 2 plus 4. Now this middle one, it would be negative 2x plus 1 quantity squared when I put the negative 2 and 3 together. I'm going to use the formula again. Square the negative 2x. What does that give you? Square it. Square that negative again. 4. Positive 4x squared. Multiply them together, which is negative 2x times 2. What's that? Negative 4x. Square the 1 plus 1 equals 18. If you forget the formula, multiply it by itself using FOIL. Okay, like terms. X squared plus 4x squared. 5x squared. Negative 4x minus 4x. Negative 8x. 4 plus 1 plus 5 equals 18. We need to set this equal to 0. Why do we want to set it equal to 0? So that we can solve either factoring or the quadratic formula. So they're going to make us work just a little bit on this one here. I might try factoring. No, I'm not going to try factoring. Quadratic formula. Negative b, 8, plus or minus the square root, b squared, that's a negative 8 that has to be squared, minus 4 times a, which is 5, times c, which is a negative 13, and it's all divided by 2 times our a, 2 times 5. Do the plus for me. Remember that you have to have parentheses around the numerator. You have to tell your calculator what's in the square root. And you have to have parentheses around the denominator unless you just want to call it 10, which is what I would do. Do the plus. See if we can get an answer that we can agree on. What do you get? 1. You get a 1. You got a 2 point what? A 2.2? So far we have 2 people and 2 different answers. See if we can agree. Just do the plus one. 2.2. What's the next number after that? 0.2.
2.2.
Exactly?
Yeah.
Let's go with 2.2. Now let's do the negative. According to the book, we're not getting the right answer.
What did you get? What does the book say? 2.6?
Did you get 2.6? 2.6 is the correct answer. Oh, should have spoken up. 2.6 is the correct answer.
Yeah.
That's for the addition. Try the subtraction.
Wait. Some negative number.
Book doesn't think it's that.
Negative, I got a negative 2. But positive,
Let me pull out my calculator. We are all over the place, is right.
All I know is I typed in exactly what that thing said, and I got 2.6.
2.6 should be one of the answers.
Oh, I see what I did. I didn't put negative data. All right. That's
I'm going to do the negative part because we hopefully got the answer there in the positive part. Let me put it over here so it's in my recorded area. I'm doing parentheses. 8 minus square root. It starts parentheses. Negative 8 squared is 64. What you can do in your head makes it easier. Minus 4 times 5 times negative 13. I'm going to close the square root, close the numerator, divided by 2 times 5 is 10. I'm going to divide it by 10, and here's my second answer. And that is correct. At least according to the book, it's correct. So, since 2 of us got it, we'll assume it's correct.
I switched up thing.
Negative 1. There are 2 x's. Let's finish this one out. X can be 2.6, and x can be a negative 1. And I get what my y's are by negative 2 times 2.6 minus 2. What's the answer when you have a 2.6 for the x? Hopefully we agree on this one. How much? Negative 7.8? Well, you can't agree with yourself.
Yeah, you can.
I mean, you can, but it's not much of a witness.
I was saying, I'm agreeing with you.
You're agreeing with what I said was right?
Negative 7.6, I'm sorry.
Negative 7. Oh!
See,
Anybody else? I mean, not that Josh is ever wrong.
negative 2 is 8.
Negative 7.2?
6 away.
What are you doing to get that?
What am I doing? Right here. Y equals negative 2 times the x, which is 2.6 minus 2 more. Do you get negative 7.2? We don't want to spend all day just entering 3 numbers in a calculator. Negative 7.2. Put a negative 1 in. Negative 2. We're going to do this in our head.
Yeah. Thank you, Mom.
Oh my. There's the answer right there. And that is the correct answer that you're supposed to get. Your assignment.
But we saw this.
From page 760, we've actually done a significant part of our assignment. Numbers 1 through 12. Then it's 17 to 24. Oh yeah, skipping 10. Skip 10. (17 through 24), 27 to 31.
It's significant.
Almost half we have done together.
Right.